total compilation in multiple rounds if you do. That is called as multi-pass compiler. That is called multi-pass compiler. Right? See this one. I want to compile a program. When you say compile a program, right? 15 lakh lines of code you have to run. Compiler is a software. 15 lakh lines of code you have to run. When you say run, this much code should go to main memory. Right? Means main memory can accommodate or not, I have to check. Suppose isn't that more main memory I have. Then 15 lakh lines of code will go to main memory at a time. Those 15 lakh lines of code is running. That is called single pass compiler. Suppose that less main memory I have. 15 lakh lines of code cannot go to the main memory. First it will go to first 5 lakh lines of code will go. It will run right on that output. Next 5 lakh lines of code on that output. Next 5 lakh lines of code, right? Like that it will come. Total compilation if you do in multiple times. Multi-pass compiler. Total compilation if you do at a time, single pass compiler. So please try to understand. Yeah, I think automatically changes will come. Now see this one. If you do total compilation, multiple passes, 5 lakh lines of code will go. Some work will be done. It will come back. Again, next 5 lakh lines of code will go. Some work will be done. Again, it will come back. Next 5. If you do total compilation in the multiple times, right? Compilation time is more. If you do total compilation at a time, one time going, one time coming, less time. So single pass compiler advantage is less time. Less time. This is the advantage. Drawback is more space. Drawback is more space. More space needed. Next one, multi-pass compiler. Multi-pass compiler. Advantage, less space. Please write properly. Drawback. Right? Advantage is going to be less space. Drawback is more time. So from this is the discussion, right? Please write properly. The discussion here is what is the meaning of compilation is going on. Remember, compiler is a software. Compilation is going on means 15 lakh lines of code is running. 15 lakh lines of code running means 15 lakh lines of code should be there in the main memory. But but main memory space may be less. If main memory space is less, so 15 lakh lines of code cannot run. So it should run in the multiple passes. So total compilation in the multiple passes, if you do multi-pass compiler. Suppose 15 lakh lines of code, right? Main memory can accommodate. At a time going, at a time compilation. So single pass compiler. If you do at a time, advantage is less time. If you do at a time, drawback is more space needed. If you do multiple times, right, advantage is with less space also you can manage. Drawback is more time. So please remember, in examination they may ask you, right, what is the advantage with the multi-pass compiler? What is the drawback with the single pass compiler? In the examination they will ask you. If you don't know the story, you may feel that complex story Reddys are left out. You may say that complex story Reddys are left out. Bacha things he explained, complex things he left out. If I don't say the story, you may feel that Reddys are done. Bacha things, right? Papa things he left out. People will think multi-pass compiler. Some people will get a heart attack. As soon as they will listen the multi-pass compiler first time, they will die. Oh, multi-pass compiler. Reddy sir said that very simple compilation. Multi-pass compiler means so maybe many steps are there. So please try to understand. If you do total compilation in multiple passes, multi-pass compiler. First of all, why are you doing in multiple passes? Main memory is less. It cannot accommodate total code. So I am doing 5 lakh lines first. Next 5 lakh, next 5 lakh, and so on. So in the first 5 lakh, listen, in the first 5 lakh, maybe lexical syntax. In the next 5 lakhs, maybe semantic and intermediate code. In the next 5 lakhs may be code optimization and target code. Some people are saying, sir, 5 lakh lines of code also, it cannot accommodate. Maybe, right? Maybe I think 5 passes. Maybe 4 passes. Passes will increase. Suppose it can accommodate 8 lakh lines of code. 8 lakh, maybe 2 passes. It depending upon how much memory you have. If you have very less memory, still I can run. The only thing is more passes. So more time. Is it perfect? Is it perfect? Let me know if anyone having any doubt. Remember, compilation is going on means 15 lakh lines of code is running. Compilation is a compiler, is a software. Compilation going on. 15 lakh lines of code is running. Running means that code should be there in the main memory. Now, can anyone help you now? How many people will give? Listen, how many people will give? Your system, this one, your computer on. What is the meaning? As soon as your computer is on, one person will be there in the main memory. Who is he? As soon as your computer is on, one person will be there in the main memory. Who is there? Your computer on means one person will be there in the main memory. Who is that? Operating system. Operating system is the one who will run always. Operating system is a one program. Whenever your system on, operating system is running. Oh, your computer is running means operating system. Your computer is on means operating system is running. Operating system running means it is a software. It should be there in the main memory. OS is, when you on the system, automatically OS will go inside main memory. It can run from the hard disk also, but it will, at the time your system become very slow. At that time your system becomes very slow. The program which will always run, as soon as you on system, immediately one program will go to main memory. That program will always run until your system will off. That is operating system. Right? In the similar way, when you compile a program, when you compile any program, you are compiling. Compiler itself is a one software. That software should go to inside the main memory. So this is the story. Total compilation at a time, single pass compiler. Total compilation multiple time, multi-pass compiler. First of all, why are you going to multi-pass compiler? I have less memory. Total compilation I cannot do at a time. So multiple passes I will do. What is the advantage you will get? Less space also I can manage. What is the drawback? More time. Single pass compiler advantage, one time going, one time coming. So less time, but more space required. So please remember, so this is not that much important, but if I don't say, somewhere you will see multi-pass compiler, single pass compiler, you will die like anything, right? Reddy sir, multi-pass compiler means compiler, Reddy sir said compiler, multi-pass means, many things left out. So be careful. Yeah, perfect. I think everything we done. Introduction to compiler, everything we done. Introduction to compiler, everything we done. Now write down. Write down everyone. First chapter. So introduction is over. Now see the first chapter. Write down lexical analyzer. This is the first chapter. Lexical analyzer. It depending upon how much memory you have. If at all time is more important, go for a single pass. Space is more important, then go to multi-pass. It depending upon. Right? If you have more memory, then go to single pass. According to your requirement. Now write down first chapter, lexical analyzer. Lexical analyzer. Can we start? First chapter, lexical analyzer. Can you say what is the purpose of lexical analyzer? What is the purpose of lexical analyzer? Everyone, whoever watching, can you say one time good evening? Whoever watching, can you say one time good evening? Say one time good evening. Everyone, say one time good evening. Yeah, fine. So first topic is the lexical analyzer, right? Everyone try to understand what is lexical analyzer, what exactly it will do. What is the lexical analyzer, what exactly it will do? So I will explain now. Everyone careful. So in my opinion, today's class is just started now. In my opinion, today's class is just started now. Observe properly. In my opinion, today's class is just started now. Just started. So try to get everyone lexical analyzer. So purpose of lexical analyzer, everyone know. Purpose of lexical analyzer, everyone know. Getting tokens, right? Dividing the given program into tokens, everyone know. That is the purpose of lexical analyzer. So I'm going to write one diagram now. See one time. Lexical analyzer. Careful everyone. Lexical analyzer. So this person is parser, which is also called syntax analyzer. Parser means syntax analyzer. Lexical analyzer, it is a syntax analyzer. Parser means syntax analyzer. It is a symbol table. Careful everyone, it is a symbol table. Request token. What is the meaning? I will explain. What is the meaning? I will explain. Take this diagram. Lexical analyzer, take this diagram. Upper one is request token. Niche one is send token. Upper one is request token. Below one is send token. A receive token, something like that. Request, receive. Request and receive. What exact meaning? I'm going to explain. Lexical analyzer. I'm going to explain. Just take this diagram. Yeah, fine. Now, after taking this diagram, can you see one more? First, listen, right? The thing which I'm going to do now, right? That one also, first listen, afterwards you can take. It is a program. Line number 1 in the program, row number 1, row number 2, row number 3, row number 4, 5, 6, and so on. Row number 20, row number 50, row number 75, row number 100. Assume this is the program. It is one of the program, user program. This user program contains 100 rows. Next one, column number 1, column number 2, column number 3, and so on. Column number 15, column number 19, column number 20. Isn't that 20 columns? My program contains 20 rows and 100 rows. I'm repeating once again. My program contains 100 rows, 20 columns. So this is the program. Roughly, this is the program. User program. Remember, within few minutes you will get everything. It is a new chapter. Everything you will get within few minutes. Concentrate properly. This is the user program. Yeah, fine. Initially, cursor is here. Program at first character. See this one. Initially I am there. Row number 1, column number 1. Initially, at this program, I am at first place. Row number 1, column number 1. It is a current status. I am not done anything until now. I didn't explain anything. One diagram I written. One program also, roughly one program I written. Please listen from now onwards, everyone. Everyone listen. If anyone says, sir, I didn't get lexical analyzer, just I started. I written one diagram and one program also roughly. Whatever needed, that program I written. Now understand what I'm going to do. Right? Initially, in the program, I am at the row number 1, column number 1. Now, one small question. Everyone, whoever watching, for all of them, one small question I want to ask you. For all of them, just I want to ask one small question. Lexical analyzer and parser, who will give tokens? Give answer. Lexical analyzer and parser, who will give tokens? Make it fast. Lexical analyzer and parser, who will give tokens? Who will create parse tree? Who will give tokens? Who will create parse tree? Lexical analyzer and parser, who will give tokens? Who will create parse tree? Out of these two people, who will give tokens? Who will create parse tree? Respond. Lexical analyzer and parser, who will give token? Who will create parse tree? Yeah, parser will create parse tree. Lexical analyzer. Parser means syntax analyzer. Parser will create parse tree, which is also called syntax analyzer. Lexical analyzer will divide the given program into tokens. Everyone know. But remember, everyone, right? Remember, this point many people don't know. Careful. This point many people don't know. People are thinking that lexical analyzer will divide the given program into tokens. Everyone saying that lexical analyzer will divide the given program into token. That is true. But you don't divide token whenever you want. Whenever parser want to token, then only you will create token. See this one. Right? See this one. Parser is requesting lexical analyzer. Hello, lexical analyzer, I got to know that you will make the tokens. Hello, lexical analyzer, I got to know that you can make the tokens. I need token. Please give token to me. Parser will ask the lexical analyzer, please give token. Because I want to create the tree, please give token. Whenever parser will ask lexical analyzer, please give token, then he will start. Then lexical analyzer then will start doing tokens. You don't do tokens by his own. Whenever parser request, then only lexical analyzer will create tokens. You may say that, sir, why parser is asking tokens? Without seeing token, how he create the parse tree? Without seeing the token, how parser can create a parse tree? You don't know. Parser want to create a parse tree, he need tokens. See, doctor want to do surgery, he need the scanning report. By seeing the scanning report only, doctor can do surgery. In the similar way, parser also, by seeing tokens only, he can create the parse tree. There is a doctor, he want to do surgery without the scanning report. How he can do surgery? Similar way, parser is saying that I will create a parse tree, but I need token. Accordingly, I can create the tree and all. Now, I think today morning also, listen, today morning I send the 2 links. Please, everyone, I think lecture number 16 in the TOC, lecture number 17, please can you complete these 2? Lecture number 16, lecture number 17, please can you complete in TOC? I'm requesting everyone. Lecture number 16, lecture number 17 in TOC, please complete. Now I will say one interesting story. Listen. Now I will say one interesting story. Everyone listen. If you observe clearly, listen. If you observe clearly, careful. If you observe clearly, see everyone. If you observe clearly, for identifiers, there is a one grammar. I goes to identifier, I goes to some story there. For every story, listen, identifier purpose in compiler, one grammar. Compiler means grammar. Compiler means rules. Compiler means conditions. Every condition you can write in the form of a grammar. So these are the grammar. See, this is the grammar. Identifier I goes to, some productions are there. These are called productions. Identifier I goes to, some productions are there. In the similar way, everyone listen. Boolean operator, Boolean expression BE goes to, some productions are there. Boolean expression, you know Boolean expression, what is the answer? True or false and not true, something like that. Boolean expression goes to. So what I mean to say is, in the C language, for every person some rules are there. Grammar is set of rules. Compiler is set of rules. Remember this. Next one. In the similar way, arithmetic operators. Arithmetic expression. It is also having some grammar. Something. I am not writing roughly. Right? Just I am giving idea. I am just giving some idea. Identifier purpose, one grammar. Boolean expression purpose, one grammar. Arithmetic expression purpose, one grammar. Everything having grammar. Next one. If at all any keyword is there, keyword purpose also one grammar. Keywords. Everything, some rules are there. Something, right? Maybe I think here 3 rules. Identifier having 3 rules. Roughly I am writing. Boolean expression having 3 rules. Arithmetic expression having 3 rules. So if anyone want to get clarity, can you please do 16, 17? Because anyhow you have to study TOC. 16, 17 you study. No relation at all. 15th lecture, 16th one, no relation. Completely free. Happily you can study. I can teach again, but unnecessary. It is wasting your time also, my time also. Those people who are not done TOC. If you are not done TOC, please can you study 16, 17. Now study 16, 17. Total lectures you can study. After completion of the whatever subjects going on. Right? Remember everyone. Everything in the C programming, identifier purpose, one grammar there. Boolean expression purpose, one grammar there. Arithmetic expression purpose, one grammar there. Keywords purpose, one grammar there. And one more thing, right? So constant purpose, one grammar there. Everything having some rules. Within few minutes, everything okay. Don't confuse a little bit also. Within few minutes, everything okay. Now, last time. Sir, you do dinner after class or before class? So, see, seriously, one class is going on. Are Ketan, seriously, one class is going on. You can play jokes afterwards. You can play jokes afterwards. Sir, can I study algorithm from your recorded? Yeah, do whatever you want. Do whatever you want. Yeah. So everyone see one time. Everyone see one time. Everyone see one time. Please observe properly. Parser saying that please give token. Parser is saying to lexical analyzer, I don't know how to create the parse tree. If I want to create the parse tree, tokens are required. Hello, lexical analyzer, please can you give token? Hello, lexical analyzer, please give next token. So lexical analyzer knows how to create token. So he will do his work. He will give token. Let's see what is happening. Now everyone listen. Now everyone listen this. Everyone listen. Initially, some people are asking, sir, initially where is the parser, sir? Initially, where is the parser? You know very well, right? It will start from start symbol. It's almost like main. It's almost like main goes to. Yes means start symbol, main goes to some production are there. Main goes to some productions are there. Now see what happened. Observe properly. So main goes to. So parser is at here. Start symbol. In the grammar start symbol, this may be yes. Normally we will say yes here. Normally we will say yes here. Let us assume that grammar is right. Parser is there initially. Start symbol, which is main. Assume that. Now see the answer. Now see the answer. So at this place. In the program, right? Can you see in the program who will present? In the program who will present? Parser will present or lexical analyzer will present? In the program who will present? In the program who will present? Parser is there in the tree. Parser is creating a tree. Parser nothing to do with the program. Parser nothing to do with the program. Parser is there in the tree. Parser is there in the tree. Parser is there here. Parser there at the start symbol. Parser there at the start symbol. Can you help me know who is there in the program? Yeah, Roshan, I will say afterwards. Roshan, I will say afterwards, man. In the middle, how can you ask? In the middle, how can you ask? Some serious story going on. Can you listen? In the program, who is available? In the program, lexical analyzer there. In the program, lexical analyzer is there because we want to do tokens. Lexical analyzer is ready to do tokens. So lexical analyzer is there inside the program. You want to say that I am ready for tokens. I am there first place. I am there first place. Lexical analyzer is saying that I am there first row, first column. I am ready to do tokens. I don't do tokens directly. If parser will ask, I will do tokens. Now parser is there in the start symbol. Parser is there in the parse tree. At the start symbol is. At the start symbol is. Start symbol is main. If you want, you can write yes also. This is main or yes, whatever you can call it as. No problem. Now see what happened. Now parser is saying that I want to create the tree. Hello, lexical analyzer, please give token. Please give token. Now observe everyone. Now observe everyone. What the lexical analyzer will do is, it will do some work. Because you know tokens, you know very well how to create token. What the lexical analyzer will do is, see this one. He will read one by one character. Lexical analyzer will read one by one character. Lexical analyzer will read one by one character. After reading one by one character, lexical analyzer, after reading one character, he got to know, because he knows very well about the rules and regulation. After completion of 3 characters, after completion of almost 3 characters, see this one, column number 1, column number 2, column number 3. After completion of 3 character, so he went to the 4th also, but the 4th one is not required. He got to know that this itself is a token. This itself is a token. This itself is a token. Now let us assume that this is int. This is int. Let us assume that it is a int. I think data type. We assume that it is a int. So it is a data type. Remember data type purpose also. Data type purpose also. One grammar is there. Everything one grammar there. Everything one grammar there. Please be careful. So S goes to main goes to if at all data type, right? If at all data type, so there is a data type. If at all S goes to identifier, there is a I. If at all Boolean expression, there is a BE. If at all arithmetic expression, there is